Hello everyone, in this slideshow we are going to see acceptance sampling plans or sampling inspection plans. A sampling inspection plan or an acceptance sampling plan is a procedure to ensure that the product gets accepted by the customer. The problem of the customer is to decide whether to accept a given lot or not. Ideally, a best policy is 100% inspection of the lot. But this procedure is very time consuming and expensive. Also, if the product is of destructive nature, like electronic components, and the lifespan of the components is to be tested, 100% of inspection of the product may result into the loss of product itself. Hence, the problem is to identify some decision rule based on the sample for accepting or rejecting the lot. Any such rule, such as take a sample of size n from the lot and accept the lot if the number of defective items in the sample is at the most C. Thus, a decision rule consists of the sample size n and the acceptance number C. The maximum number of defectives allowed in the sample are known as acceptance number. So such a decision rule, which consists of sample size n and the acceptance number C, is called as acceptance sampling plan or a sampling inspection plan. A good sampling plan should always have high probability of accepting a lot which consists of least proportion of defective items and a low probability of accepting a lot of higher the proportion of defective items. The acceptance number, as I said, is the maximum number of defectives which can be allowed in the sample in order to take the decision of whether the sample is to be accepted or not. Acceptable quality level is the quality of the product which according to the producer will be accepted by the customer. It is generally denoted by P dash or P bar. Producer's risk is the probability of accepting Producer's risk is a probability that a lot which gets rejected by the customer is actually a lot of good quality according to the producer. So it is a probability that a good quality lot gets rejected by the customer. Generally it is denoted by alpha. So alpha is the probability of rejecting a good lot, that is a lot of quality P dash, which is the acceptable quality level as studied above. Lot tolerance fraction defective is the worst quality of lot which the customer is ready to tolerate, generally denoted by PT. Consumer's risk is the probability that a bad quality lot gets accepted by the consumer. That is the lot which is of quality PT, it is the worst quality of the lot. It is generally denoted by beta. So beta is the probability of accepting a bad lot, that is a lot with quality PT or a lot with fraction defectives equal to PT. Now with this introduction, let us look at a single sampling plan. Now from a given lot of size n, capital N, if a sample of size small n is taken without replacement, we first carry out 100% inspection of this sample of size small n. Let D be the defectives found in this sample. We will now compare the value of D with the acceptance number C. If number of defectives in the sample is less than the acceptance number C, the lot is accepted by the customer after getting the D defectives replaced by non-defectives from the manufacturer. But if the number of defectives in the sample is greater than the acceptance number C, the lot is rejected by the customer, and in such a situation, the producer will carry out 100% inspection of this lot. Now, since the decision of accepting or rejecting the lot is taken on the basis of only one sample which is drawn from the lot, such a sampling plan is called as a single sampling plan. Now, let P be the quality of the lot. By P, we mean the proportion of defectives. Let us define PAP as the probability of accepting a lot of quality P, that is a probability of accepting a lot containing P defectives. If P is PAP is the probability of accepting a lot of quality P, it implies that in this lot the number of defectives D should be less than or equal to C, which can be written as summation D going from 0 to C, probability that number of defectives in the sample is D. So this D can vary from 0 to C if the lot is to be accepted. Now if P is the quality of the lot, out of capital N items, N into P items are expected to be defectives and the remaining N minus NP are expected to be non-defectives. Now these D defectives will come from NP defectives and N minus D non-defectives will come from N minus NP non-defectives. Hence the number of ways of selecting D defectives is NPCD and number of ways of selecting N minus D non-defectives is N minus NP C N minus D. Also, the total number of ways of selecting N units from capital N is NCN. Hence, the probability that the lot contains D defectives is NPCD into N minus NPCN minus D upon NCN, summation D going from 0 to C. Now, if the ratio of sample size to population size is less than or equal to 0.1, then the probability can be approximated to binomial distribution. Hence, probability of accepting the lot of quality P is summation D going from 0 to C, NCD, out of N there are D defectives, into P raised to D 1 minus P raised to N minus D. Further, if this P is less than 0.1, it can be approximated to Poisson, where PAP will be given as summation D going from 0 to C, e raised to minus NP, NP raised to D upon D factorial. Now, if alpha is the producer's risk, which is the probability of rejecting a lot of quality P dash, in terms of PAP, it can be written as 1 minus PAP dash. Hence, PAP dash is equal to 1 minus alpha. Now, beta is the consumer's risk, which is the probability of accepting a lot of quality PT. Hence, in terms of probability of accepting the lot, it will be PAPT. Let us now define average outgoing quality. Average outgoing quality is the quality of the lot which is accepted by the customer. By quality of the lot, we mean average number of fraction defectives in the lot which is being accepted by the customer. Hence, AOQ is defined as expected number of defectives in the outgoing lot upon the lot size. If X is our variable consisting of number of defectives in the outgoing lot, there are two possibilities. If the lot gets accepted, the T defective items are in the sample are replaced by non-defectives. Hence, the number of defectives in the accepted lot will be NP minus D, because NP is the total number of expected defective items. Now, if the lot gets rejected, the producer is going to carry out 100% inspection of the lot. Hence, the number of defectives in such a lot is going to be 0. So, we shall multiply the number of defectives by the corresponding probabilities in order to obtain the numerator, that is the expected number of defectives in the outgoing lot. That is, AOQ is a expectation of x upon n, where expectation of x, that is summation xpx, will be np minus t into probability that the lot is accepted, PAP, plus 0 into probability that the lot is rejected, that is 1 minus PAP. So this simplifies to np minus d into PAP. Let us substitute this value. So we get NP minus D upon capital N into PAP as the expression of AOQ. Now, if a sample is a true representative, then D can be estimated by NP. So in that case, let us replace D by NP, and we find that P is common. So if we remove P common, we get AOQ as capital N minus small n upon capital N into P into PAP. If n is very large, that is the population size is very large compared to the sample size, then the ratio in the bracket will be approximately equal to 1, and therefore AOQ will be P into PAP. If we try to plot P, that is the fraction defectives, on x-axis, and for these various values of P, if we try to plot AOQ on y-axis, this is the shape of the curve that we get. The number of values of AOQ goes on increasing. It reaches a peak as the value of P increases, and then it starts decreasing, and as and when the number of defectives become bigger and bigger, the number of items in the outgoing lot will tend to 0. Now the peak of this curve is called as AOQL, that is maximum AOQ. The value of AOQL is obtained by producing a perpendicular from the peak to the y-axis, and the value read on the y-axis will be the value of AOQL, that is our average outgoing quality level. Average total inspection denotes the average number of items inspected in the outgoing lot. Again, let us define a variable, which is the number of items inspected in the outgoing lot. Let P be the quality of the lot. If n items are inspected with probability PAP, the lot is accepted, and 100% inspection is carried out if the lot is rejected. That is, capital N items are inspected with probability 1 minus PAP. If we try to write the distribution and calculate the expectation, this is what we get: small n into PAP plus capital N into 1 minus PAP. If we try to rearrange the terms in the second expression and we try to open the bracket, we can write this in terms of simplified expression. Hence, ATI will be n plus capital N minus small n into 1 minus PAP. Operating characteristic curve, also called as OC curve. It is a curve where the probabilities are plotted on x-axis and the probability of accepting the lot is plotted on the y-axis. On x-axis, we have the quality of the lot being plotted, and on y-axis, the probability of accepting the lot of that particular quality is plotted. Now you can see that this is a Z-shaped curve, and it depicts that as long as the quality of the lot is good, that is the proportion of defectives is less, there is high probability of accepting the lot. The probability will be near 1 and it goes on decreasing slowly initially, but it drastically goes down as soon as the lot quality drops and then remains steady at a value very nearer to 0. So this is the operating characteristic curve with a Z shape. An ideal OC curve is of Z shape. Probability of accepting the lot is 1 when the lot quality is less than PT, and it will be 0 when the lot quality becomes greater than PT, and hence the sudden drop in the graph. An OC curve can be used to improve the quality of the lot so as to minimize the risk. It will depend on, when you actually plot the curve, what shape does it assume. Let us now see an extension of single sampling plan just as a concept, that is a double sampling plan. Now, as the name suggests here, the decision of accepting or rejecting the lot is taken on the basis of two samples, hence it is called as a double sampling plan. If you look at the flow chart, it suggests that if your lot consists of n items, first select a sample of size n1. 100% inspection of these N1 units should be carried out. Let D1 be the defectives in this sample. If D1 is less than or equal to C1, accept the lot. If D1 is strictly greater than C2, reject the lot. And if D1 lies between C1 plus 1 and C2, select another sample of size N2. Carry out 100% inspection of this sample. Let T2 be the defectives observed here. If the number of defectives of both the samples D1 and D2 is less than or equal to C2, accept the lot, otherwise reject the lot. Here there are two samples of size N1 and N2 and there are two acceptance numbers C1 and C2. So this is the procedure which we just saw for carrying out a double sampling plan. And since the decision is taken on the basis of two samples, the procedure is known as double sampling plan.